Hello, I'm back. I've got a different coffee mug though. This is my son's artwork from fourth grade. Good morning. How's your quarantine? Mine's all right. Sleeping a little better, not really. Um, so we're gonna start at the beginning and we're gonna talk about numbers. Before we do anything in mathematics, we have to understand what we're counting, right? So before we get into numbers, just to make it like right now, right? We're counting cases of the coronavirus, and then we're counting like human lives that are lost from it, right? We count all sorts of things. We can count how many cups of coffee we have in the morning, and then if we have a lot, then we start counting by pots. So I had 6 cups. Oopsies! Now I had 1 pot. Well, make another, right? So we count a lot of things. So I've got some random stuff around that I'm going to use. Um, So we'll get into the symbols we use for numbers later, but you should remember we use a base 10 system. This is very important. We're using 10, right? We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the thing is actually, what do when we hit 10? Then we do 1 and a 0, right? So we have 10 digits. 0 is one of them. Clocks, although mine is stuck right now, is base 60, right? We get this. 60 seconds per minute, 60 minutes per hour. A quarter of an hour is 15 minutes. Clocks, actual old school clocks, if you only have digital clocks or you only have like Alexa to keep the time for you, get a real clock. Get a real clock. It helps children so much learn their numbers and understand things. And then even use phrases like half past or quarter after. They're little things that make a huge difference when a child only has like a phone and everything's digital. They don't understand that stuff. But when you take this, and P.S., it's a circle, so it's like geometry, right? So simple thing you can do, get an actual old school clock. It helps with angles, it helps with numbers, it helps with bases, it helps with so many things. Okay, so I'm really going to try to keep this to 10 minutes. But this is like, okay, numbers. This is one of my favorite things. So back in the dawn of time, right, when we were all barely hunter-gatherers, usually people started counting with their animals, right? So you have a pen with your sheep, and what someone would do, I'll pretend to be my forebear. You take little stones, maybe. I'll have my green marker. But like, I see a sheep leave the pen, and I put a stone on the ledge. And then I see another one, and I put another stone on the ledge. So they go out to pasture, and I've got these stones lined up. And then as they come into pasture, I just move the stone back. And as long as all the stones are gone, I know I have all of my sheep. It's a very one-to-one relationship. And if you didn't let any sheep out of the pen, you didn't start counting. Because we were just counting. It's like right now with the coronavirus, like, when we didn't have any cases, we weren't counting it, right? So those are called natural numbers, okay? So they get this fancy symbol here. It's really just like a bold N, and it's natural numbers. And maybe you remember these. They're just counting numbers, right? Just basic counting. You can't have a half case of coronavirus. You're gonna have a half case of corona. But you get what I'm saying. So you can't have a half case of the coronavirus, so you either have a case or you don't. We're counting in natural numbers. Now, maybe when you were younger, you didn't understand why do we differentiate natural numbers from whole numbers. And I forget what the symbol is for whole. But the whole numbers, so counting numbers, 1, 2, 3, 4, and so on. Whole numbers are natural numbers just plus 0. So that goes 0, 1, 2, 3, 4, and so on. Okay? This is a big deal, which we can talk about later. And your children will not understand the differentiation, and you probably don't either. And there's a lot of lore and misunderstanding about 0. Okay? Some people see it as a numeric black hole where, like, there's God. And, like, that's the same as infinity. People have been murdered over 0. It's true. I mean, not anymore, hopefully. Okay. So, what we erroneously call whole numbers is when we're usually talking about integers. So let's think for a second. We'll do a little thought exercise because integers require that. And most math teachers, when they're teaching these numbers to students, they'll be like, well, let's say, I've done this so many times, I'm sorry, it's really dorky. Like, let's say you're going to the mall and you want to buy a sweater and you have $20, but the sweater's $25. What do? And then you get students to be like, oh, I have to borrow $5. And it's like, well, how do we write the borrowing, right? We introduce the idea of negatives. Negatives are an idea. It's just the idea of the absence of something. So we come up with this sort of tilde, which is just a slash, right? And it means negative. It's just a symbol to say to say indebted is a simple explanation. But so integers, these are natural. It's a Z. That's from its Latin reason, I think, Latin, are integers. And people, when they usually say whole numbers, they actually mean integers. So integers are the whole numbers, 0, 1, 2, 3, forever, but also they go the other way. So you owe me $1, you owe me $2, you owe me $3, and so on and so forth, or however you want to say that. You'll notice I'm not using a number line. I know many people think, like, probably when you were learning math, it was like, I mean, the number line is like, but conceptually, it was genuinely groundbreaking, and it remains so. Okay, so we've got this. These are all real numbers. We're not going to talk about imaginary right now. Yes, imaginary numbers exist, and they're also real. We'll get into that later. Okay, so now we've got this, but I'm going to show you, here's my extraordinary example, because most of my math improv involves just grabbing whatever's on my desk. So here is the roll. We're eating real healthy over here. This is the roll that was my son's. How do I quantify this? Okay, if you would like to take a nice look, it is clearly not a full roll. It is a fraction of a roll, right? So much like my cup of coffee, if we decided what became full, right? We've all gone to Starbucks, haven't we? Well, not now, but where you get your coffee and then you take the lid off and you're like, it did not fill. I said I want it black. I do not need room for cream, right? But so well, how do we decide what that is, right? So those are now rational numbers, which I'm gonna get some coffee and then we'll write it down. Okay, so rational numbers comes from ratio. Ratio is fractions, and rational numbers, here it comes, is not a big Z, it's a big Q. Or it's not an R, because something else is for R. Real gets the big R. Real gets the big R. Rational gets Q for quotient. Because quotient and ratio are fractions. So rational numbers become, the way dorky math people write it, is plus or minus like A over B, meaning any number, positive or negative, so all these, but that can be written as fractions. Written as fractions. Now, we're going to talk about decimals and fractions in the next thing. I have like a minute left. I'll try to, I still have one more number set. Now I'm not going to write it this way because that's going to be super obnoxious. So we would say plus or minus, A over B, where this is super mathy, but we're doing A and B are in integer sets. So that's what this means. Mathematicians are always looking for ways to do shorthand because ideas are big. So math takes ideas and makes it shorthand. So we say A over B, where A and B are integers. The ergo, that's why you never have a decimal in a fraction. Never. It's not done. It's not. It's because it's to differentiate between what's rational and what's coming next. I know you know it. What's our prefixes to take the opposite value is irrational. So we get the double I, irrational. And irrational are numbers that cannot be written that way. There's a very famous one right here. Maybe you recognize the symbol. I'll do it in the next thing because I'm at 10 minutes. But if you were to do a diagram, we'll do it right down here, of the real numbers, like a circle, you would have the natural numbers are in here. Then right outside are whole numbers. Maybe you remember this. And right outside that are integers. And outside integers are rational. And then over here are irrational. And all of these are real. That's why we use symbols. So what that means is if I have the number 2, 2 is natural, and it is whole, and it is integer, and it is rational. It can be written as 2 over 1. If I have the number -3, it's not natural. It's not a counting number. It's not whole. But it is an integer. So it starts out here. It doesn't go in the inner circle. And then out, out. Okay? Irrational numbers are all over themselves. We'll take a little moment on that in another moment. Because it's now 11 minutes and I need to shut up and get some more coffee. So it's really good. Every math class I ever took, starting in like 7th grade until through my math degree and beyond, actually. The very first lesson was always number sets. And then we started having the first lesson being about proving the existence of the number 1. But it all goes back to number sets because it's very important that we understand those basic concepts. So if you or your children can remember those sets, the vocabulary of that is actually really, really, really helpful as you go on. And it's relatively simple. It's what? Natural, real, natural, whole, integer, rational, irrational, imaginary, 8 things. As a small child, you really only need to know the first 3. But depends on what level of math you're doing. Anyway, that's how we start algebra. Onward!